My name is Florence Chardon, and today I will be presenting to you a research project I've done in the field of green chemistry, specifically chromatography, as an intern last summer at Genentech in South San Francisco. So our efforts were focused on rendering purification a greener process and, in essence, trying to reduce the environmental footprint that chromatography leaves behind. So some research interests of mine in the field of green chemistry are to be able to reduce the amount of hazardous waste in pharmaceutical research activities, to eliminate chlorinated solvents from purification and thus making it a more sustainable practice. Some key facts to keep in mind is that organic solvents are the largest contributor to hazardous waste in pharmaceutical research activities, and they comprise over half of the total material to manufacture drug substances, which is huge and a large part of the reason why we're researching this topic. And so, in essence, our research goal is to develop a new solvent system that is greener and more sustainable to be used in chromatography. Some project details. So the three solvents that we decided to use in this solvent system are isopropyl acetate, methanol, and heptane, and varying the ratios of these allowed us to see which one would work best. And we tested these solvents on a pharmaceutically relevant compound set, which we put together based on Lipinski's rules for a molecule to be able to be a drug. And the solvent systems were tested on both thin layer and column chromatography to really ensure applicability in the end. And so after running these solvent systems on TLC plates, we found that the 3-to-1 ratio of isopropyl acetate to methanol and heptane was just as good as a methanol and DCM system, which is traditionally used for the separation of polar molecules. And here in this image, you can see that the separation with the 3-to-1 system is just as good, if not even a little better, than the methanol and DCM system. The bottom plates are run in the newer solvent system. And then after doing the TLC portion of this project, we wanted to make sure that this solvent system could also be used in flash column chromatography. And here we see two chromatograms. The top one is run in a methanol and DCM system, 0 to 20%, and the bottom one is run in the newer 3-to-1 isopropyl acetate to methanol and heptane solvent system, also run on a gradient from 0 to 80%. So the most important results are that the peaks are similarly spaced apart, which lets us know that the separation is just as good. And an added benefit to this new solvent system, since it is less polar, is that we reduce the solvent front effect, which is an added benefit as well. After doing all of the data analysis of this project, we created these graphs to really aid chemists from moving from a methanol and DCM solvent system to a 3-to-1 isopropyl acetate to methanol and heptane solvent system. So the whole purpose of these graphs is to go to what percentage methanol and DCM you're used to using, and then being able to see what the equivalent percentage is in the new solvent system. And then furthermore, the last part of this project was we wanted to make sure that it would be easy for chemists to use, so we stored solutions of isopropyl acetate and methanol over time, and we wanted to make sure that there was no transesterification going on. And so we analyzed this with NMR and headspace gas chromatography, and even after storing solutions for up to 60 days, there was no evidence of transesterification, which allows us to say that these solutions can be stored over long periods of time. So in conclusion, we would like to say that substituting dichloromethane is a very feasible possibility, and this system that we recommend is a 3-to-1 isopropyl acetate to methanol system. It was successful with both thin layer and column chromatography and achieved just as good of separation. And furthermore, replacing dichloromethane in chromatography will benefit the environment, the health of those working with these chemicals, minimize worker safety concerns, and save on waste disposal costs. Thank you.